All right, this part of the chapter is going to be looking at the differences between acids and bases. We're going to look at what acids and bases are. We're going to look to see some of their common physical characteristics, how they're different structurally, and then we're going to see what happens when you mix them together. Now, acid-base reactions are an example of a metathesis reaction, and we talked about those last time. A metathesis, or a double replacement reaction, is one in which the cations, the positive parts, and the anions, the negative parts, switch places. We have a couple different types of metathesis or double replacement reactions. And before we talked about precipitation reactions, in which one of your products actually forms a solid, and you use your solubility chart to be able to predict what that solid is. Acid and base reactions are another example. So here are some just common everyday acids and bases. You're much more familiar with them than what you realize. So for the acids, we have anything from vinegar to vitamin C tablets to lemon juice. Your bases include Drano, so sodium hydroxide, ammonia, milk of magnesia. And down at the very bottom, it looks at some of the differences of trying to identify whether a substance is an acid or a base using what's called litmus paper. So like I said, acids and bases are really, you're quite common with them. So let's look at some common acids. So we talked about vinegar that has acetic acid in it. Lemons have citric acid. The hydrochloric acid in your stomach, which allows for your food to digest and break down. Vitamin C, even liquids in car batteries. Do you know what that liquid is? So it turns out in most of your car batteries, you have sulfuric acid. And did you know that car batteries can explode? I've had it happen before. It's not fun. All of a sudden I heard this big boop, and then there was battery acid all over my engine. Oh, what a mess. Now, there are some physical characteristics, physical similarities between your acids. Number one, they'll have a tart or a sour taste. Now, remember the Twinkie, we never ever taste things in the lab, but you've tasted these in real life. I remember many years ago, I was traveling back to Kansas with my daughter. We were living in North Carolina at the time, and she was really young. I mean, she wasn't even eating solid food yet, and I was having a heck of a time at the airport. We had a big layover. They'd taken my stroller. I was frustrated and angry and overwhelmed, and so I decided to go have a drink at a establishment there at the airport. And so in my drink, they had a lemon. So I gave my daughter a lemon. Oh, isn't it so much fun to watch a little kid while they're trying to eat a lemon and their face gets all puckered up? Can you feel it in your mouth right now? Can you feel that little bit of a sensation there? Yeah, lemons have acid. Acids have that tart or sour taste to it. But again, remember the Twinkie, no tasting in the lab. They'll turn litmus paper red. We'll see an example of that in the lab. And acids can corrode some metals, which was a problem when I had battery acid all over my engine. So I actually had to go through and neutralize that acid. Now, bases include the lye and drain cleaners. Now, lye is just sodium hydroxide. Maybe you've heard of lye before. Maybe you've talked about lye soap. Well, lye soap is used with that same base, that sodium hydroxide. And if you watch some old movies like Fight Club does it, there's a series called Justified that I know they have a episode where this happens, where usually some bad guy is trying to make some innocent person do something absolutely horrible. So they pour sodium hydroxide pellets on their hand. And when you're watching it, you're like, yeah, they're pouring some plastic pellets on their hand. Yeah, big deal. But it's actually sodium hydroxide, this strong base, and it will burn. It hurts so bad, and it can scar really, really bad if you're exposed to a lot of a strong base or a strong acid, doesn't matter. Now, luckily, what we work with in the lab is pretty dilute. It's been watered down. We talked about dilute before. We'll talk about dilute again in one of the upcoming sections. But the strong acid or a strong base can hurt you. I actually have scars on my elbow from when I was making lye soap, and it was my own fault. I wasn't being careful enough. I spilled some of the lye, and I got it on myself. And yes, it left a little scar. It happens. So be careful with strong bases or strong acids. Other bases include milk and magnesia, household ammonia. They'll have a bitter taste. Remember the Twinkie, don't taste anything. They turn litmus paper blue, and they have a slippery feel. Well, I was just talking about using lye to make lye soap. Well, what you do to make soap is that you take this strong base and you react it with a fat or an oil. Well, if you think of your hands, they actually have oil on the surface. So if you're exposed to a base, it could react with the oil in your hands and actually make soap. So if you get something on your hands and you go wash them off, but you still have this like really, really slippery feel, you probably were exposed to a strong base, and we need to take an extra step to help neutralize it. It won't be bad. So if you go back to those scenes in Fight Club and Justified, the cure that once that innocent person agrees to do whatever horrible thing they want him to do, they just take vinegar, which is a weak acid, and they pour it on that sodium hydroxide to actually neutralize it. Who knew something as simple as vinegar could help stop this horrible burning sensation? So anyway, if you have a and it's really, really slippery feel on your fingers, let me know. We'll treat it. You'll be fine.